So in this session, we are going to take up with the discussion of one type of a data structure, so which is single linked list. See, I have written, so it is singly linked list. So by using a single linked list, right, how we are going to represent its data and its memory location, how we are going to arrange the data. Okay, so all these things we are going to discuss with one type of an example. See, what are all the points which I am going to tell in this session is very important. So important in the sense that in comparative examinations, they may ask you in MCQ type of questions. So friends, so please make a note of whatever hints I am just telling in this area. Okay friends, so you might have watched my previous video of introduction of linked list. Okay, so after watching that, you just come over here so that you will be having a continuity of understanding the session, otherwise you cannot be able to follow it, right friends. So and I also request you, all of my friends, to please subscribe this channel so that it will be a great motivation for our team, and so that we can also put more videos which will be very useful for all of you, right? So now this is the actual structure of the single linked list. So you see, in the last class I told about an example of people forming a chain. So in the same way I have written over here. So see, data and a pointer. Data and a pointer. So like this we must have to represent it. So here the next is nothing but a pointer variable. Okay, so what is a pointer? By using the pointer we are going to refer to the value that is being present in one of the memory location. Am I right? By using that pointer variable representation, we are going to refer to the successive memory addresses that are being stored in this single linked list. Okay, so what is a single linked list? So a single linked list is, we are using only one pointer for referring to the next value, that is to the next data that is being stored successively. See, we are using only one arrow mark. Okay, so what is the meaning? So now this is a data. For example, one data is being stored here. Along with that, we are giving a memory address value. So this memory address value will tell that it is going to give the value that is being stored in this memory address. See, this is my data stored. Along with this data, I have given one memory address. So this memory address, if I go, I can get this value, right? Can you follow? Similarly, if I go to this data after referring to this memory location by using this pointer variable, along with this data value, I will be attached with that of a memory address location. So suppose if I go to that memory address location, I will be able to get the data present in this memory location, right? So here you see it is a null. So what is the meaning of null? I have discussed in the last class. So the meaning is there are no more elements that is being connected. So this is the last data value that is being present in this data structure. Friends, are you all able to follow? Right. So now this is one example. So first let me explain you, then I will tell you what is this, right? So now you see, as I told in the last example, there are three persons. So what are all the names of the three persons? See, so the first person is Hari. So the second person is Joe and the third person is Tom, right? So these are all some sample examples I have written. So now you see, if I ask Hari, okay, so if I ask Hari, what is the nearby person that is present with you? Like this, if I am asking Hari, what he will be telling? So he will be telling that by using this information, whatever he gathered, that is, this is your address value. Okay, for example, information, according to this I am telling you. Oh, okay, according to the information, that is a memory address, he will tell that his name is Joe, right? Like this he will be telling. Then after going to this Joe, I will be inquiring Joe, what is the next person present? Okay, so what he will do? He will be using this memory address. So what is the memory address? X100. So this is the memory address attached with this Joe. So he will tell that the next person present is, by referring to this memory address, that it is Tom. Okay, right? So now I will be going to this location. So now I will ask Tom, what is the person next to you? So what he will do? He will be seeing this information. So that information is null. So what is the meaning? There is no more person attached along with this Tom. Can you understand? So like this, for each and every data, I am attaching a memory address. So if I go to this Hari, I will use this memory address X001. So this is a memory address. Okay. So when I go to this memory address, so like this I will move, right? So if I go, what is the value stored under X001? It is Joe, right? So along with this Joe, there is another memory address. It is X100, right? So when I go to this memory address, I will be taking the value as Tom, and that's all. So this is the last value. There is no more reference. So friends, like this only we are accessing the data structure of singly linked list. Can you understand? So now the next point what you must have to notice, see, the arrow marks are moving in forward direction, right? So the arrow marks are moving in forward direction. So what is the meaning? What is the meaning? So I can be able to get the value only in forward direction. See, the hands are being caught up in one direction. Okay, so other hands are being free. So they are all forming in only in one direction. So the forward person only will be telling the forward values, right? So see, the direction is in this way. There is no reverse direction. Okay, so this type of connection is called as single linked list. Okay, so what is the disadvantage here? If you see, if I want to, I will be asking Joe to tell me what is the person present before you, right? What is the person present before you? Can he be answering it? No, he cannot able to answer because there is no arrow mark. If there is only arrow mark only, he will be asking. If there is no arrow mark, how will he will be answering? No, it is not possible. So this is one drawback, right? Please make a note here, reversing is not possible. Another point what you must have to notice, see, what is the value of the memory location? See, it is X001. So this is X100. Okay, so is there any similarity, that is there any relationship present between this memory address? No, there is no relationship because it is a random memory address generation. So what is the meaning? We are storing the data value in different way of using memory addresses, right? So we are not following any sequence in representing the memory addresses. See, for example, if there is any linearity that we are going to follow, so if this is X001, it will be X002, X003 like this, isn't it? But here it is not like that. We are using different memory address values for storing the data. Can you understand? So what is the meaning? Linked list, a data structure, that is a single linked list or whatever type we are going to discuss in future. All the linked list is going to follow non-contiguous memory allocation. Okay, so non-contiguous memory allocation. So this is a very important point. So please make a note. Meaning is it is going to store the data in different memory allocations. Okay friends, are you all clear? So now we will go for the next discussion. A new node is arriving. Okay, for example, as I told in the example, a new person is coming. We are going to insert it in the middle. Okay, he is asking, so the person name is Lily. So he wants to get added in between Harry and Joe. So how can I add it? So what I will be doing is, I am going to adjust this hand. Okay, so hand or link, whatever it is. So I am using this hand. Okay, so what I will do, he will be asking permission. So after the permission is being granted, what we will do is, Hari will first give the hand to Lily, isn't it? So Hari will give the hand to Lily. Okay, so now Lily, what he will do, he will be connected to Joe. So like this, he is getting inserted. Can you understand? So like this, we are adjusting the pointer's value. So now what I should have to do? So now what is the next person of Hari? It is Lily. Okay, so now what will be the value of the memory addresses? So first, after inserting the pointers, I must have to change its memory address location, isn't it? So because there will be some problem while using some pointer connections. So now what I should have to do is, now for example, X001 will be referring to this location or any other memory addresses what we are giving. So now if x001 is being asked, it will be giving the Lily value. It will be giving the Lily value. So now x300 will be pointing to this location. Can you follow? Friends, are you all clear? So now this is the way you must have to connect it. Friends, are you all clear? Now another one new node is coming. It wants to get inserted in the middle. What I should have to do is, in normal example, I must have to disconnect the already present connection. Then I must have to link the connection with new node on both the sides. It is a normal example what we will be doing in chain formation, friends. Please just make a match between those and then you just come to an idea, right? So now you see how many pointers are getting adjusted. Can you please tell me the answer? So this is a very important question they may ask. In single linked list, if I want to insert a node in the middle, how many pointers are getting adjusted? By seeing the diagram also you will be able to answer. Please tell me what will be the answer. Just think and tell me. So here, what is the number of pointers? This and this. Am I right? So total number of pointers while inserting a node in the middle, it is going to be 2. Please make a note. It's a very important question, right? So now, for example, I want to insert this node in the front. Okay, so I want to insert the node in the front, that is he want to get a join in front of Hari. What I should have to do? Is there any other node present in front? No, nothing is present. So what I should have to do? Very easy, make the hand of Lily to join with that of Hari. Because this hand is free only, isn't it? So he will directly connect it. There is no need of disconnection and connection. Am I right? Is it clear? So now, what will be the number of pointers needed for inserting in the front? So it is 1. So insertion in the middle is 2. Insertion in the front is 1. Similarly, insertion at the last will be what? Same. It is 1. See, if you want to insert here, like this I will be inserting. Okay, so what is the value? For example, any other value. So x005, it will be giving on memory address. So in that memory address, I will store this Lily. Can you understand? So like this only you must have to arrange. So please make a note 2, 1. So this 1 is for front and last insertion and 2 is for middle insertion. I think so. Now it is very easy to understand. Am I right, friends? So now one more point I have left out, isn't it? So this one. So this node is called as a header node or it is called as an avail node. So please make a note. So what is the use of this node? So it is similar to that of recycle bin that you are using in your computer. What you will be doing in recycle bin? Please think and tell me. So whatever files that we are deleting, okay, at current it will be stored in that recycle bin area or in a folder. So for example, unknowingly if we deleted some files, after certain days if you want to reuse that file again in my folder or whatever it is, I will go to the recycle bin and if I press restore, it once again it will come and get stored. Am I right? So the same thing we are using in avail. So avail is a node which is used for storing all the nodes which are deleted or which are inserted, that is informations regarding all the nodes which are being inserted or deleted. Okay, so it is like a recycle bin or another name also we can tell it is as a garbage collection. So both are having the same meaning, isn't it? So these are all the very important points, friends. Have a note, right? So in the next class we are going to discuss with doubly linked list.